Hello everyone, welcome to Invention Tales. In the early 1940s, as World War II raged across the globe, a quiet revolution was brewing in a dimly lit British laboratory. Alan Turing, a brilliant mathematician with a restless mind, was not only deciphering Nazi codes with his enigma-breaking bomb machine, but also pondering a question that would change the course of history. Can machines think? In 1950, Turing published his seminal paper, Computing Machinery and Intelligence, introducing the Turing test, a bold challenge to determine if a machine could converse so convincingly that it could fool a human into believing it was one of them. This idea was radical in an era when computers were hulking, room-sized behemoths capable only of crunching numbers, not mimicking thought. Turing's vision planted the seed for artificial intelligence, or AI, a field that would one day reshape the world, though he would not live to see its full bloom. The dream of thinking machines was born, but the path to its realization would be fraught with challenges, triumphs, and unexpected turns. By 1956, the spark of Turing's idea ignited a formal movement. At Dartmouth College in New Hampshire, a young computer scientist named John McCarthy organized a summer workshop that would become the birthplace of AI as a discipline. McCarthy, alongside visionaries like Marvin Minsky, Nathaniel Rochester, and Claude Shannon, coined the term artificial intelligence, defining it as the science of creating machines capable of tasks requiring human intelligence, such as reasoning, learning, and problem-solving. The Dartmouth Conference was a crucible of optimism, with attendees believing that intelligent machines were just a decade away. Yet the reality was sobering. Computers of the time were painfully slow, with limited memory, and the complexity of human thought proved far harder to replicate than anticipated. Early AI programs like the Logic Theorist, which could prove mathematical theorems, showed promise, but progress was glacial, and funding began to wane. The 1960s and 1970s became known as the first AI winter, a period of skepticism and reduced investment as the field struggled to live up to its lofty ambitions. Despite these setbacks, the dreamers persisted. In the 1980s, AI saw glimmers of hope with expert systems, programs designed to mimic human expertise in fields like medicine and engineering. These systems, such as MySyn, which diagnosed infections, showed that machines could make decisions, albeit narrowly. However, it was a chess match in 1997 that thrust AI back into the spotlight. IBM's Deep Blue, a supercomputer designed to play chess, faced off against world champion Garry Kasparov in a historic showdown. Using brute force calculations to evaluate millions of moves per second, Deep Blue defeated Kasparov, marking the first time a machine had bested a human champion in a complex game. The victory was a milestone, though Deep Blue's approach was far from human-like thinking. It relied on raw computational power, not intuition or learning. Still, it reignited public fascination with AI and proved that machines could excel in specialized tasks, setting the stage for greater breakthroughs. The true turning point came in the early 2000s, fueled by a perfect storm of advancements, faster computers, vast amount of data, and a new approach called machine learning. Unlike earlier AI, which depended on hand-coded rules, machine learning allowed computers to learn from experience, much like humans. Pioneers like Geoffrey Hinton, Yann LeCun, and Yoshua Bengio, often called the godfathers of AI, championed neural networks, computational models inspired by the human brain structure. These networks, when trained on massive datasets, could recognize patterns, from identifying faces in photos to translating languages. The internet, now a global repository of data, provided the fuel while affordable, powerful hardware, like GPUs, supplied the engine. In 2012, a neural network called AlexNet developed by Hinton's team, stunned the world by achieving unprecedented accuracy in image recognition, surpassing human performance in certain tasks. This breakthrough, powered by a technique called deep learning, marked the dawn of modern AI, transforming it from a niche academic pursuit into a technological juggernaut. By 2025, AI has woven itself into the fabric of our lives. Virtual assistants like Grok, created by xAI, answer questions with wit and insight, drawing on vast knowledge bases to assist users instantly. Self-driving cars navigate bustling cities with precision, relying on AI to process real-time data from sensors and cameras. In healthcare, AI systems analyze medical images to detect diseases like cancer with accuracy rivaling top doctors. Creative fields have been revolutionized too, with tools like Midjourney generating stunning art and music from simple text prompts. Yet, AI's rise has not been without controversy. Ethical concerns, bias in algorithms, privacy invasions, and the potential for job displacement have sparked global debates. For instance, biased datasets can lead to unfair AI decisions, while the automation of tasks threatens industries like transportation and customer service. Companies like xAI are working to address these challenges, prioritizing transparent and ethical AI development. The story of AI, from Turing's wartime musings to today's transformative technologies, is one of relentless curiosity, ingenuity, and ambition, but it also carries a responsibility to shape a future where machines serve humanity's best interests. As we stand in 2025, the saga of AI is far from over. Researchers are exploring quantum computing to supercharge AI's capabilities, while others dream of artificial general intelligence, machines that can think and reason across any domain, not just specific tasks. Will AI one day surpass human intelligence, or will it remain a powerful tool in our hands? The answers lie ahead, but one thing is certain. The journey that began with Alan Turing's bold question has transformed our world in ways he could scarcely have imagined.